Before we begin Unit 26, here is the answer to the Unit 25 question. The best answer is choice B.
Scientists have been able to conclude that carbon dioxide levels have never been as high as they are today, and that there is a definite correlation between increasing carbon dioxide levels and the average surface temperature of the Earth. In only a few centuries, human activity is shifting the climate patterns of the world. As their climates change, plants and animals may no longer be suited for the new environmental conditions. It's unfortunate that for social, economic, and political reasons, some people are choosing to ignore and even trying to discredit the science that explains and proves climate change, yet none have ever been able to provide any legitimate evidence to the contrary. Unit 26. Please flush.
Water pollution can be defined as water containing any unwanted or undesirable substances.
Obviously, there are different types and degrees of water pollution, and it seems to be everywhere you look.
When water pollution comes from a specific site, such as a factory or outfall pipe, we refer to it as point source pollution.
When it originates as field runoff or from discharges that are not easily identified, we call it non-point source pollution.
There are many sources of water pollution. A few examples include industry, mining, parking lots, agriculture, power plants, and the list goes on.
The negative effects of water pollution extend far beyond the sight of trash littering a stream.
Water pollution includes, but is not limited to, infectious agents or pathogens that cause disease, plant nutrients that lead to excessive algal growth, wastes that deplete oxygen that aquatic organisms need, toxic chemicals that poison wildlife, sediments that can cause illness, and thermal pollution that can disrupt an organism's life cycle.
Water is often referred to as the universal solvent because it dissolves so many things.
As a result, water is probably the most versatile cleaner available, providing the Earth with its own built-in purification mechanism.
When it rains, contaminants in the air and soil dissolve in the water and are removed from the immediate environment.
However, water's impressive dissolving properties lead to an important question. Once substances are dissolved in the water, how do we get them out?
The amazing answer is that nature cleans water for us. It does this using nothing more than natural physical or biochemical processes and doesn't even charge us for the service. This is how it works.
As water evaporates, it turns into gas, rises in the atmosphere until cool enough to condense back into liquid form, then falls back to Earth as rain or snow.
During this physical transformation, any dissolved particulate contaminants are left behind and the resultant rainwater is relatively pure.
When gravity causes water to percolate through the soil, larger materials are also physically removed by filtration.
Then there are the natural purification systems that involve biochemical processes capable of removing dissolved organic contaminants.
During microbial decomposition, organic pollutants are often removed or converted to less complex substances through assimilation.
These physical and biochemical processes are completely natural and have been occurring for eons. You will soon see that we have learned to take advantage of these natural cleaning mechanisms.
If nature is providing us with these natural methods of purification, why is there still a concern over water pollution?
First, the human population has so overshot its carrying capacity that these natural solutions simply cannot keep up with the incredible amount of biological waste we produce.
Second, humans synthesize chemical substances that are non-biodegradable. Since these new materials had not naturally evolved to exist on our planet, microorganisms capable of assimilating them have not had the opportunity to co-evolve.
As a result, once these substances are created, they are here to stay, unless chemically altered again by applying human technology.
Of these two major water pollution problems, the extraordinary amount of biological waste is the least difficult to address.
To solve this problem, all we have to do is use the Earth's natural cleaning mechanisms, but do so on a much larger scale while speeding up the process. We call this wastewater treatment.
As for the non-biodegradable and unnatural substances, they must be handled on a case-by-case basis.
Many people have no idea what actually happens when they flush the toilet. Before the water in that toilet can make it back into a stream or river, it has to go through a purification process. Although there are many variations to wastewater treatment systems, most are quite similar.
Once flushed, the wastewater moves through the sewer system to a centralized processing plant, most often located near a major stream or river.
The initial wastewater treatment step, known as primary treatment, removes solids using physical separation techniques.
The water first enters a chamber that allows grit and large objects to settle out by gravity.
It then moves through a screen made of metal bars that collects the large debris. This bar screen is periodically scraped to remove collected materials.
The wastewater now moves into large circular containers called primary settling tanks, where the rate of flow is decreased to allow particles to settle by gravity. Like the bar screen, the bottom of the primary settling tanks are periodically scraped to remove the solid wastes.
Primary settling tanks are often referred to as clarifiers because the wastewater leaving them is visibly clear, although far from clean.
At this point, most of the solids have been physically removed using filtration or gravitational settling, but the organic matter will still need to be addressed.
In the next phase, secondary treatment, organic material is broken down into less complex forms.
The wastewater moves from the primary settling tanks to structures that resemble huge swimming pools the size of school cafeterias, where hungry microorganisms are waiting for what they consider lunch.
Massive aerators are used to pump in the oxygen-rich air that the microorganisms need to digest their food. Eventually, the microbial assimilation results in wastes of far less complexity.
These materials are removed and sent for further processing in systems known as digesters that get their name from the fact that they work similar to our stomachs in breaking down material into usable forms.
It should be mentioned that another technology is sometimes used instead of or in addition to aeration tanks. They are called trickling filters. The concept of microbial degradation is the same, however, the water is sprayed or trickled over a bed of rocks instead of held in large tanks.
The final step in the wastewater treatment process is disinfection.
Methods include chlorination, ultraviolet radiation, or use of ozone to kill any pathogens that may still be remaining in the waste stream.
At this point, the water is now ready to be discharged into the stream, river, or other receiving surface water system.
There are certain criteria that must be met for the processed water before this effluent can be discharged.
Depending on the receiving water, governmental agencies have set standards that treatment facilities must meet in order to remain in compliance.
Local agencies usually monitor compliance and enforce these standards.
If you're thinking, is that all? Remember that this process has simply prepared the wastewater for discharge to a river, not for drinking.
Here's where nature takes over again, as biochemical assimilation will continue to further degrade any remaining waste.
There's one more issue that must be addressed before leaving this topic.
You may recall that during primary treatment, materials were physically removed by bar screens and primary settling tanks.
Secondary treatment waste from digesters, aeration tanks, and trickling filters were also produced.
These substances are now considered solid wastes.
Disposal of solid waste will be covered in a later unit, but for now, you may find it interesting that, with minimal treatment, a large portion of these solid waste can be used as soil conditioner or fertilizer.
Now that you have a basic understanding of how wastewater is treated, be sure you can distinguish that from water treatment.
Water treatment refers to the steps that are taken once water is removed from a source in order to make it safe for drinking.
In a nutshell, water treatment uses a series of filtration, disinfection, and sometimes pollutant-specific procedures to make sure that water is both potable, drinkable, and palatable, tastes good.
Most developed countries have set strict guidelines and monitoring protocol for the quality of drinking water that comes out of the tap.
Treating wastewater for discharge and preparing resource waters for drinking may address the first problem posed by water pollution. But what about those non-biodegradable substances that people have created, but nature never intended to be on this planet?
The truth is that these problems must be solved on a case-by-case basis.
There are countless examples of unnatural water contamination requiring innovative technological solutions. The 2010 British Petroleum Deepwater Horizon incident is a remarkable case study.
The oil well explosion released unnatural amounts of crude oil in a short period of time, impacting the Gulf of Mexico's many aquatic and coastal ecosystems.
Scientists quickly developed innovative methods of secondary treatment, including the use of nanoparticles capable of dissolving the oil.
Unfortunately, these types of unnatural problems are often further complicated by feasibility or economic constraints, even when technological solutions exist.
Obviously, these unnatural, non-biodegradable water pollution problems require a lot of time, money, and resources to rectify, reminding us that pollution prevention remains our best solution.
Mathematics and physics teachers are finding many interesting ways to infuse the fundamentals of water and wastewater treatment into their instruction, and the students are loving it, especially the yucky parts.
However, regardless of what you teach, the next time you see a sign that reads, "Please flush," you may take pride in knowing that you're the first step in a long road to providing clean drinking water for someone else.
Then again, the next time you take that first sip from the fountain, you may remember the sign. Here's your question for Unit 26.
Which of the following statements is true?
Choice A. Water is often referred to as the universal solvent because it dissolves so many things.
Choice B. Nature is unable to clean water for us using natural physical or biochemical processes.
Choice C. The introduction of synthetic and non-biodegradable substances is the least difficult water pollution problem to address.
Or Choice D. Water treatment is another term for wastewater treatment.
The answer and explanation are provided at the beginning of Unit 27.